Okay, today we're going to talk about square roots in this vlog. Now, in order to understand square roots, you have to really understand squares, perfect squares. We've discussed perfect squares in the past, and we're not going to spend time on them now. So we know 3 squared is equal to 9. Okay? Now the next one over, we have -3, the quantity squared. So -3 times -3 equals +9 as well. Okay, and lastly, what times what equals 9? There's 2 examples, 2 answers for this. So it means when we say 9, it's a perfect square, meaning the square root of 9 is 3. Now we'll look at the next 3 examples. We'll see if they are perfect squares or not. So A. Now if you think about perfect squares, 1 squared, 2 squared, I would recommend you kind of study those and know those. Make a table for yourself. So 64, I'm aware that 64 is actually 8 squared. So then the square root is 8. It's like you're undoing the square. 8 squared is 64. Square root of 64 is 8. It's how it works, okay? You're undoing the other one. Now this one, B. Now, square roots, like of 64, on the square root of 9 over 16, you can take square root of 9 and square root of 16 separately, and it becomes 3/4. But to understand, it's positive and negative. If you multiply 2 negatives, it's a positive answer, or of course 2 positives multiplied is a positive answer. Now look at C. Square root of -36. Negative. Square root of a negative. There's no answer for that. Well, I'm sorry. There is an answer, but there's no real number answer for that. Okay. Real numbers. What does it mean? They got fake numbers now? No. Real numbers is a real number system. It's not an imaginary number or complex numbers where you have negatives in the square root. We're facing and working with a real number system here. In other vlog series, we will discuss imaginary numbers. And we'll see this letter I introduced. Now, we have to decide and work with these square roots. Examples A through F. Now, the square root of 144, we're going to focus on the positive square roots. It's called the principal square root, one we always think about first. Square root of 36, 6. Square root of something is that. Really, It's plus and minus 6, but we always focus on the positive, just because it's natural. For now, we'll focus on the positive answers. Understanding they have negative answers, though, just so you can understand that. Now, as we look at this example, the square root of 144 equals 12. We have a square root of 4/25 equals 2/5. We squared the numerator and the denominator. Negative square root of 16 over 49. We keep the negative. It's negative 4/7. Now the square root of m squared equals m. Now if you remember, with even powers, like m squared, you can divide the power in half. It's n times m to the first. You add them, it gives m squared. So m squared has a square root. It is a perfect square. Okay, in these last two examples, sometimes we have a number times a square root symbol, like 6 times square root of 25. If 25 is a square root, perfect square, we would take 6 times the answer, 6 times 5. And like we have negative 3 times 10, negative 30. Let's move on. Now, numbers with perfect squares are called rational numbers. They have the answer is a rational. You can write it as a fraction. There's no decimal. You know, it's rational. Now, square root of 121 is 11. So the square root of 5 is not a perfect square, right? There's no square root for that. There's one that's not a perfect square for a square root. It means it's an irrational number. It means when they have as a decimal, it'll be 2 point and a whole bunch of numbers, and it's a never-ending number, never repeating. So there's no way to write it as a fraction. It just goes on forever. Now C, negative times the square root of 16. Well, square root of 16, there is one of those. It's 4. Therefore, the answer would be, it's rational. So yeah, that works. So the answer would be, for the square root of negative 9 is not a real number. 9 is a perfect square, it's 3, but the negative inside does not have a real number solution. And the last one here, Negative 17 is no real number there either. Okay, now we're going to talk about radical expressions. So we have the square root of something. Square root of 13 squared. The square root and a square really cancel each other out. One undoes the other. The answer is just 13. Okay. Now, negative times the square root of 29 squared. Well, okay. I know the square root of something squared, they cancel out, it becomes 29. But the negative is an interesting case. Let's write this down. Now, our next example. The square root of 3y squared. And that cancels each other out. The answer is just the inside. So now, example D. We have the power rule. So you have square root of 2 squared and negative 3 squared. Let's break it up and make it clear. Okay, so we split it up. So negative 3 squared is 9, and square root of 2 squared is 2. Now I have to multiply them together again. 9 times 2 is 18. Now for our last example. We have the square root of 3x squared plus 4 squared. If we're squaring a square root, they cancel out. And we simply answer with the inside there. And that's our answer. I hope this discussion with square roots and what they mean in perfect squares helps you from out here on out.